Hannah, we have you back, and I will share your presentation, hopefully. You're on mute there, Mohana. So
Can you? Yep.
yeah, I can. There we go. Now, can everyone see that?
Yep.
Okay, you can let me know when you want to move on.
Yep.
Okay.
Okay, hi everyone. I'm Mohana here, and I have been in this GIS and remote sensing field for almost 15 to 20 years. Actually, I have actually a basic degree in civil engineering, and then I also did my master's in remote sensing and GIS, followed by working for both service-based and product-based companies, using remote sensing and GIS, largely in the area of application of agriculture, risk, and insurance. Before joining my PhD, I worked for a longer period with a company called RMS, which is a product-based company which deals with developing catastrophe risk models. So where actually I use GIS and remote sensing in developing a hazard model. So that helps in improving the accuracy of the loss calculation due to different, events, like due to different catastrophe events. And after that, I joined my PhD in 2016. My PhD is about assessing the impact of extreme weather events on, grass-based livestock production on Irish farms, where I looked at the relationship between the extreme events and how it affects the farm input and farm output. The farm input, I'm talking about the farm feed usage. Is there is any change in the silage yield on the farms, as well as the use of concentrates and other bulky feeds. And also I looked at the farm output in terms of milk yield. Is there is any because of the different extreme weather events, like in 2018, like in 20, different time period, 2003, is there is any effect of like heat stress on animals and animal milk yield. So that was my PhD all about. And I started to work as a research officer from 2021 October until end of last year. So whereas actually I was part of a Terrain AI team, a multidisciplinary project, which actually aimed at developing a better understanding of greenhouse gas emission, across different land use. So I was involved in cropland as well as in grassland. So one of the work that I did during that time, I'm going to present it in detail. So it was about detecting absence of intercover crops using Sentinel-1, using different machine learning algorithms. So next, please. Introduction under this schemes like Fifth Nitrate Action Program and Acre schemes, it is actually how do you say, it is important to actually plant cover crops on tillage ground following summer harvest. Establishing these cover crops is an important management process in order to mitigate greenhouse gas emissions and also improve the water quality. So these cover crops actually capture the nitrates from previous crops and prevent it leaching into leaching or leaking into the nearby waterways. And also it reduces soil erosions and improves the soil organic matter. And you can also use this cover crops as a fodder for the livestock. And so the aim of this project is like, it is important if you look at in the context of GHG emission like modeling, like greenhouse gas modeling, it is important to determine the spatial temporal statistics of cover crops in Ireland, for determining accurately the greenhouse gas, how much is produced and how much is removed from the atmosphere. Next, please. Because we are looking at a larger area, on-site farm surveys may not be actually practical in those situations, because the costs associated with is high, as well as it requires, a repeated monitoring. So there comes the use of remote sensing. So at the moment, like we have multiple high resolution spectral temporal images are available, which are optical, which are already proven valuable in monitoring the agricultural activities on the ground. But because of the cloud coverage issues over Ireland, it's very difficult to use this optical images. So the aim of the project is to how can we use synthetic aperture radar in the place of optical to determine, detect fields in Republic of Ireland who doesn't grow the winter cover crop. Previously, there were like very few studies where they have used a combination of both Sentinel-1 and Sentinel-2, and there are also studies where they have used Sentinel-1 but they have used for a very longer period. Actually, they used from September to March of the next year. But because of the limitation, I'll explain why I have taken like a short period here. Here, actually, I used only from images from October to early January to determine the, whether they are growing the cover crop or not. Next, please. Before going detail into it, I want to the study area here. I want to show you the study area. The sites, actually, these sites are part of Terrain EA project, but I have to select it based on the, availability of reference images. Here we didn't do any kind of ground truthing. Here we have used the Sentinel-2 as well as the Google Earth images. So mainly there are two sites. One is Lallimore site, other one is Gorey site. The Lallimore site was actually used to train and test the model. So where I have actually taken 18 Sentinel images from October of the previous year to January of mid of the next year. So like 18 images. And I have used the LIPIS parsers to determine, to get hold of the fields. I have got hold of fields. I did not only use the crop fields, but I also used the permanent grassland fields to train the model that there is a presence of vegetation. So here, actually, for the training, I have actually used 311 parcels. And for the testing, again, on a different time period, I have used Gorey site again, but for the different year, I have used from October to January of 2020 to 2021. Here I have used like 695 parcels, and these are the different time period Google Earth images and Sentinel images I have used to, given to understand what that parcel is, whether it's bare or whether it's completely vegetated, or is there any sparse vegetation which is resultant of previous harvest, but because over the time there is always a growth which I'm calling here as a sparse vegetation, which is ideally we can call that also as a weed. So here, actually, I have used both GRD images as well as the SLC images in determining the objective of the study. Next, please. Before going in detail into that, I would like to show you the timeline of the cover crops. So generally, these cover crops are sown prior to 15th September as a part of acres requirement, and you have to use different types of crops that you can use, and it should be remain in place until 1st of December. This is the only limitation here. I'll tell you why. And grazing of the cover crops is also not permitted before 1st of December. And generally, these cover crops are actually destroyed back into the soil before sowing cover crops in, cash crops in spring. So if you look at that, so we have only information from September to November. It means that we are very sure that there is no disturbance or any activities going between the September to 1st of December, and we are not sure like whether the farmer actually allow for any grazing or allow for any cutting or something. So we decided to look only from September to early January here from the study. So again, the question comes here, definition of bare soil. Should we have to consider only pure bare ground as a bare, or should we also include like a few spots of like sparse vegetation? I mean the weeds, whether should we consider in the bare, or should we have to consider into the vegetation, completely vegetation, which is actually an ambiguity here, which I'll explain in detail. But for the study, actually, I have used only two classifications. One is bare, the other one is non-bare. Non-bare consists of both vegetation as well as the sparse vegetation. Next, please. So this is, I just want to show you, this is the processing steps that I have used for processing a GRD. So actually here in the study, I have used only one orbit, ascending orbit, in order to reduce the difference in the backscatter due to angle of incidence angle. And then I applied these different types of like processing. And so the resultant is the 5 different variables. The one is RVI. The RVI actually is called actually radar vegetation index. It's very similar to NDVI, but it is derived from the SAR data set. In addition to that, I have used 2 different variations of RVI. In addition to that, in addition to the intensity default bands VV, VH, and the ratio of 2. And I have stacked all these 18 images into one, and then using the LIPIS parcel data, which is again corrected for field, like because a single parcel may contain multiple fields. So actually I used a field actually here. and derived statistics for each of the field. So I have derived statistics. It's not only mean, but also did like standard deviation, min and max. And these are the 5 different variables that are resultant of this process. Next, please. Similarly, I did for SLC. So the resultant are the entropy, anisotropy, alpha, and these are the C11, C12, and all these. So these are like the resultant from the SLC. So these are different bands and their statistics. Next, please. So the method, because in this study, actually, we cannot use a single cutoff threshold to determine whether it's a bare or not bare, because for the same field, if there is any difference, if there is any issue with the drainage, or if it rains, because rain actually, SAR actually is affected by the, dielectric constant, mainly, I mean, if there is any rainfall, there is actually significantly, there is a, how do you say, increase in value. So we decided not to use any kind of like a single cutoff threshold. So we decided to go with the machine learning. So here actually I use like 2 different types of algorithms. One is a non-time series where I have used a simple random forest and support vector machine. In other ones, I have the second, given the nature of the data is like a, sequence time series, I decided to use a time series classification. Here I have used like 4 different time series classification: TS, forest, rocket, DRCF, and HC2. And so here I have used this Lallimore site. Sorry. So here I have used the Lallimore site as a part of my training and testing. I used like 70% of my training data into the machine learning classification, and then I tested the 30% of the Lallimore site. In addition to that, I said like I have used a Gorrimore site of different time period, because it differs in terms of like soil and all, drainage and everything, and also different time period. I want to see the evaluation and determine the best perform model. Next, please. Next, please. So before going and showing the results, I would like to show some of the plots here. This is actually a multiple time series plots for the images that I have from October 2019 to 2020 mid-January. So these are 18 images, and I'm showing you here the sigma naught parameter. In this study, I want to show you, tell you one more time, I have used both the sigma naught as well as the gamma naught, but I'm just showing you for the moment, like I'm showing you the sigma naught. And actually I'm showing, this is categorized by field type, whether the parcel is a bare, or is like completely vegetated, or is there is any like a small, like a presence of like sparse vegetation, which is ranging from 0 to 10, 10 to 20 to up to 100. So here you can see that alpha, here you can see alpha, anisotropy, entropy, which are resultant of the SLC products, and rest of them are resultant of the GRD product. The default band, which you can see the VH and VV here, you can clearly see that these 3 classes can be differentiated to a greater extent in VV when compared to the VH. And also you can see that in RVI and RV4SI and other SLC band, it can be clearly seen that from like 276 a day, 276 to up to 300, which is these are the images of October, where it is very difficult to differentiate the bare from the rest of the classes, because there is so much of mixing here. But you can see after from 1st of October, you can clearly see that the bare can be easily separated from the the non-bare classes here. And moving on now to the next slide, I'd like to show you the same plot, but for the single date. I just want to show you how the SAR data is very much different from the NDVI. So this is for the 14th of November 2019 for the bare site, for just only one day. I'm just showing you here. So this one here is for the NDVI. Okay, we have only one optical image NDVI here, and rest of them are SAR derived. So here actually I classified based on the type, which is bare, sparse wedge. You can see in the NDVI plot, you can clearly see that it can easily, differentiate between the bare, sparse wedge, and wedge. But if you look under the other different, variables that are part of SAR, there is large of overlapping between the classes, So which is why SAR is slightly difficult to, extract or can be used in this kind of classification. But if you look at VV and VH, when compared to VH, VV is much better in classifying these three different classes. This is just to showcase that how optical is different from a SAR, you know. Moving on to the next slide. I also want to show you the, the class called sparse vegetation. It's very easy to classify between the bare and vegetation, but the sparse vegetation is something that it's creating problem in this study, which I will explain here. You can see that I have this is for the Lallimore site and Gore site. I'm using only the VV and VH band just to show you. So this is for the 18 images. I have only taken the sparse vegetation class, and the color that I have used from green to blue, that represents the percentage of vegetation cover. You know, the light green represents the very, very minimal cover, like just a spot somewhere, or if you look at the 90 to 100%, which means that it's largely covered by vegetation, but it's like a sparse vegetation. But if you view this in eyes are a bit, but we view in NDVI, generally it will be how do you say that it will be in the color ranging from green to blue. But here you can see that in SAR, how we view in NDVI, but in SAR it's very different. There is even the high vegetation cover has low value, and low vegetation cover has high value. This is actually a issue with the SAR data. But let's see how actually SAR has classified, using how has classified whether it's presence of winter cover or not. Moving to the next slide, please. So there are three different models that I have used. The first one is like, can I just use only one day image, like the day where there is no rainfall? I mean, if there is 2 consecutive days, if there is no rainfall, I decided to use, using that just one image, is it possible to determine whether they grow or not the winter crop? And the model 2, I have used the multiple time series. I have used the 18 images, but I have also split them into different ranges. Like if you look at on the right side, you can see the image duration. I have used image duration, like I have used all images. I have used like few set of images from different time periods to see if there is any difference, with the way that improves accuracy. Here for the model 2, I have used only 2 different algorithms, which is the non-time series. Model 1, model 2 both has non-time series algorithm. But for the model 3, I have used all the images, but I have used only the time series classification algorithm. So I have used I have constructed multiple models that uses different time, image duration, and different variables. I used single variable, I used a combination of variables, So I'm just going to show you only valid results that have come out of better ones. Next, please. So this is the result of model 1. I'm just highlighting only the better ones that are resulted from the model 1. So here actually the variable that I have used is the ratio of VV and VH, RVI and RVI for forest 1. I'm not showing you here the trained model results. I'm showing you only the test model results of Lallimore and Gore here. So if you look at the producer accuracy and user accuracy of the Lallimore, it's almost like 71 and 84. But whereas in Gore, the accuracy gets flipped, which is very difficult to understand why the accuracy gets flipped. So we decided not to go ahead with this model 1. So I decided to check the model number 2. Next, please. So model 2 actually, which is a multi-SAR scene model. So where I have used only a variable which is VV or VH, the ratio. And of different time periods, I said like I have used 0 to 17, which means that I have used all the images. And 0 to 13, I have used images up to mid of December, like from October. And the T5 to 13 is like only I used images from November, not from October, again up to December. And here I have used again images from different time periods. So of different time periods, I found that the images which I have used all the images, and the images from November to end of December has given me the highest accuracy. But the accuracy is again low, which is like both are like close to like 70%. So I decided to try with multiple scene model, but using the time series classification algorithm. The next, please. So this is the result of model 3. So here I'm just showing you only one algorithm result, because this is the better one when compared to the rest of the 4 algorithms. So TSF is time series forest actually given me a better result. So again, here I'm showing you only the result of the GRD. I'm not showing the result of the SLC because the SLC didn't perform well. Only the result is I'm showing is from the GRD. So where you can see that the Lally-Moore test for the ratio VV and VH is almost like 95 and 97, which is very high. And also the go rate test slightly gone down, but it's much better than the previous one that we have seen. So the producer accuracy that we have derived from this is like 87, and the user accuracy is 70. And RV, in compared to ratios VVVH, RVI has slightly higher accuracy and higher K kappa as well. And next, please. So I'm in the top left hand. I'm just showing right hand. I'm showing you here the result of the better model here. So here actually on the top is the actual, and the side is the predicted ones. So you can see that of 140 actual bear, my model has predicted 124. And the remaining 16, it is classified as non-bear. It is very difficult to say why the 16 has been classified as non-bear. So I decided to see, is this because there is any growth happening in this between these two periods, from November to December or something. So I used NDVI to see, but there was no growth happened during that time. And there were also studies that shows that because of the the ridge orientation, the ridge orientation and the geometry of the ridge of those cover crops, that may influences. So actually I got hold of ridge directions from the Google Earth. There is no any one particular direction that contribute to that. So it's very difficult to understand why. But because we don't have access to the geometry of that, and also we don't have access to the dielectric constant, surface roughness, so that could be one of the contributing factors. So definitely this study has to be extended to understand why the 16 fields are classified as a non-bear. But if you look at the non-bear category, 511 fields has been classified correct out of 555. The 44, which is non-bear, is going into the bear class. But when I looked at the 44, of which like 95% of the 44 are sparse vegetation. So sparse vegetation is here a problem because sometimes it goes into the the bear, and a lot of them also go into the non-bear. So the overall accuracy that we have is around like 90%, but the user accuracy remains low here, 74. Because of the issue with the sparse vegetation class. So the finding actually, the study finding actually indicate that SAR time series sigma naught, backscatter the VV, VH, RVI, and RV4SI actually offer valuable insights into the status of the agriculture field. Of different algorithms, we have used the time series for algorithm perform much better when compared to the non-time series that we use in largely. And the utilization of the multi-time sensor is much more effective than using a one time period image. And so this, at the moment, like the problem is that we have only a strict time scale for the cover crops to be in place. So we have only from October to 1st of December. Only recently in the last year, they have increased it to the 1st of January. So that we have to actually make further more strict action is needed, that there should not be anything, should not be, any kind of activity should not be happening in the ground, so that we can actually increase accuracy. And I would say like ground truth, if we have actually access to any ground truth data, we'd be better understanding why this 16 and 44, is going into, is classified wrongly. And we can actually further improve the accuracy by integrating with optical cloud-free images if we happen to get that. So this actually, the figure shows the actual and the predicted. The ones which are in brown color are the bare ones. This is actual, but the predicted actually over predicted, over classified my model. So with this, I'm going to finish. Thanks. Thank you all.
Thank you very much, Mohana. I can totally appreciate the joys of the challenge that Irish weather holds when you're trying to use SAR. Obviously, the optical is only going to be good enough for a certain piece of for a certain period of time, and obviously SAR is the go-to. And then also the accuracy of your models is very much determined by how that works as well. And the moisture, as Sita has just mentioned there, she mentioned that you mentioned moisture impact on radar. So are you eliminating any scenes, days based on rainfall?
Yeah, that's main. I mean, I use both only the one incident angle, like the ascending orbit image, as well as the days without no rainfall. I'm taking it, which is why I have like less number of images. Otherwise, I'd be having more number of images, you know, that I can use.
So as I say, weather is the problem really here in a lot of it, in terms of, you know, weather and then the type of ground cover. Just when you mentioned there, in terms of ground truthing and ground truth improvements, did you get any ground? Did you do any ground survey?
No.
Okay.
No. Because it was actually a 2019 and 2020, so we don't
all
have
right.
any
Okay.
information.
Yes. That didn't help at all. Did you use the LPIS data boundaries, I'd assume, for your field boundaries? But did you
I have
get
corrected
any?
the boundaries. Actually, I have corrected the boundaries for the hedgerows and corrected the boundaries, because it has multiple number of fields inside a parcel. So
That's
I have to,
yes. Because like, to be fair, the multiple fields can sometimes be just down to crop usage and stuff like that. So I was wondering, did you even get any of the declared crops from the LPIS, or did
no,
you
from
bother?
the LIPIS. From the LIPIS.
You did. Yes. Okay, well, even that is that will help your algorithm to a certain point, but like that, not so much, I suppose, if you have a catch crop or something where it's a very short window, it's there and then it's gone, and like that, you know, you do need
because we don't see a big trend like that we see during like a main growing season. So the trend is very minimal.
It's not too many like beans in the corner of a field or something like that. So, and as they're very hard to catch. If literally the catch crop is hard to catch if you are you know, restricted by weather and
also
optical.
we have restrictions. Only this year they have increased this catch crops to be remain in place from 1st of December to 1st of January. I think they should extend to kind of like to end of February or end of January or something, you know, so that we have more better we can actually, because of the growth will be high, so that we can better classify that one.
No, that's I appreciate all those challenges completely. So, and like that, can, you know, two nice areas as well for that work, you know, Gorey, and then what, I can't remember the name of the other spot, but Midlands, and it's very good.
Because sorry to say that, because most of the previous papers that I have examined, they have used the same site and tried to see the, you know, test the model, but they have never tested on different site and different time period, just to see how the model performs, you know. So that's one.
And in fairness, it has to be somewhere where there is tillage and crops. It's not all over the country, so you kind of, at least if you move around, you can test it again. Excellent. Anybody, any other questions for Mohana or Adele? One question from Sita through her colleague Sandra Malloy. Has there been research into winter cover crops has been published anywhere?
Oh yeah, actually they were like, they were like previously, there are like 2 studies where they have used the combination of both Sentinel-1 and Sentinel-2, and also they have used Sentinel-1, but they have used this random forest and support vector meshing, and they didn't reach the accuracy that what we reached using the time series classification.
Time series is for the win. That's basically, yeah, exactly. Excellent. What time? We're coming up to 3 minutes to 2. So I think if there aren't any more questions, we could probably wrap it up for this series. Obviously, if you have any more, you can throw them into the chat there, or you can follow up with both of our presenters today. So a big thank you from EUROGI Women in Geospatial to Idel and Mohana for joining us today and giving us their time and discussing their projects, which are both very interesting. Our next webinar will be on Wednesday, the 1st of May. So it's the first Wednesday in each month. And we will post all of that information on our LinkedIn page. I've thrown the LinkedIn link into the chat there. So yeah, keep an eye on us on there, follow us on there, and we will have some other initiatives on the go over the next few months. So also anybody else out there that would like to take an opportunity to discuss their project or speak at this webinar, anything in the wider geospatial or EO is very welcome. So you can get in contact with us through our LinkedIn page. And I said thank you so much to the ladies there. That's very enjoyable, very enjoyable. And we will have these presentations up on our I was going to say our website, YouTube channel at some stage over the next week or so. So thank you to everybody, and enjoy the rest of your day. And thanks very much for joining us.
Thanks, Marion.
Thank you.
Thanks.
Thank